The concept of energy conservation is a fundamental principle in physics. It states that energy cannot be created or destroyed, but can only be transferred or converted from one form to another. When it comes to mechanical energy, it encompasses the sum of kinetic energy, gravitational potential energy, and thermal energy. In this virtual simulation, we will delve into the explanation of conservation of mechanical energy and how it is affected by the changes in mass, friction, and gravity, using the example of a skater. To begin with, let's understand what exactly is meant by kinetic gravitational potential and thermal energy. Kinetic energy is the energy possessed by an object due to its motion, while gravitational potential energy is the energy stored by an object when it is placed at a certain height in a gravitational field. Lastly, thermal energy is the energy associated with temperature and the movement of atoms and molecules. The conservation of mechanical energy can be explained by taking the example of a skater gliding down the hill. When the skater starts moving, he possesses kinetic energy as he is in motion. As he gains speed, his kinetic energy increases, and when he jumps, he also gains potential energy due to his height above the ground. However, as he lands back on the hill, his potential energy is converted back into kinetic energy, and he continues to skate with the same amount of total mechanical energy. Now, let's consider how changing the mass, friction, or gravity affects the skater's energy. If we increase the mass of the skater, he will have more kinetic energy due to his increased body mass. And if he jumps, he will also have a greater amount of potential energy. However, this also means that he will require more energy to move and maintain his speed. Hence, his kinetic energy will decrease over time. Similarly, if there is an increase in friction between the skater's skates and the hill, more energy is lost in the form of thermal energy, causing a decrease in the skater's total mechanical energy. On the other hand, if gravity is increased, the skater will have more potential energy when he jumps, but he will also have to exert more force to overcome the increased gravity, resulting in a decrease in his kinetic energy. In conclusion, the conservation of mechanical energy is a crucial concept that explains how energy is conserved and transformed in different forms. By understanding the different factors that can affect mechanical energy, we can better understand the behavior of objects in motion and their energy transfer. So, the next time you see a skater gliding effortlessly on the hill, remember the principles of energy conservation and how they are at play in that simple act.